Have you ever gazed up at the night sky and wondered what lies out there, beyond the skies, our planet, and our galaxy? Or were you ever fascinated with the rocket launches and new discoveries on the news? On the other end of the spectrum, many would disagree and find space exploration an utter waste of money. For instance, in the last year alone, NASA spent over $18 million on space exploration and research, and although it's only 0.5% of the total US federal budget, that's still a lot of money. Which brings us to the question, why are we exploring space? Is space exploration really worth the investment? How will space exploration impact us? And how much of the universe can we actually explore? With the rapid development of space technology, space exploration has been made easier. Just look at what Elon Musk, the CEO of SpaceX, did. He sent a small payload into space that consisted of an old red Tesla sports car with a space-suited mannequin strapped to this driver's seat, and the radio set playing the David Bowie soundtrack. In fact, early this year, SpaceX, an organization with the ultimate goal of providing reliable and safe transport of satellites into orbit, launched the SpaceX Falcon Heavy. The rocket is designed to be reusable and transport a payload of around 5 large elephants in space. It also has a performance double the world's next powerful rocket, the Delta IV Heavy, but at 1/3 of the costs. With such modern-day technology, there is a lot of potential for us to reach space and explore the universe beyond what we know. Furthermore, there are even more possibilities for space travel technology that we know of and have laid down theoretical framework for, but haven't gotten around to realize. These include nuclear pulse propulsion, where nuclear reactions are used to directly propel the craft via the massive force generated, and solar sails, where the radiation pressure of sunlight drives a large mirror-like structure. Other ideas include Bussard ramjets, ion thrusting, nuclear thermal rockets, and MPD thrusters. Any of these may see use in expeditions to star systems far away, being generally more efficient and enduring than chemical rockets. As our scientific knowledge expands more, we may see more exciting and feasible ways to advance into the so-called final frontier. Space exploration is not just about discovering new stars and planets through telescopes, because it also involves us sending out probes and astronauts to explore celestial objects at close distances. The main reason why we invest in space exploration is because of the economic benefits it brings us. Through the exploration of space and space research, our vision and understanding of the universe expand, giving us more information to develop space technology to benefit us on Earth. It is because of this, since NASA's establishment in 1958, that many U.S. presidents have had a major play in the U.S. civilian space efforts, with each president's emphasis on space exploration as the overriding goal for NASA. Space technology has also been recognized for its strategic importance and possible role in military affairs. This was demonstrated in space-based missile defense systems designed during the Cold War, and more recently by President Trump's declaration of establishing a space force. In addition, space exploration gives us ideas to improve life on our own planet, such as making the World Wide Web truly global by launching large satellite constellations in space to allow global access to Wi-Fi and to provide high-speed global internet coverage. An idea recurrent in sci-fi pop culture is that space exploration can help us to find planets that will be suitable for us to migrate to, which will allow us to reduce the effects of overpopulation and avoid climate change on Earth. Currently, there have been a few plausible planets such as Ross 128b, which can be further determined by exploration using drones to explore the environment. Space exploration may also allow us to discover other forms of life in the universe. And distributing human civilization via galactic colonization would also decrease chances of species extinction in the event of a catastrophe. Though these benefits seem very far away, it gives us hope for humanity's survival in the very, very distant future. However, despite the many benefits space exploration can bring us, there are still many unpredictable and unknown risks in space. Popular sci-fi films such as Arrival, Gravity, and Interstellar have no problem portraying these tragedies and accidents, and unexpected errors occurring in space are bound to happen. For example, the Space Shuttle Columbia exploded during re-entry in 2003, killing 7 astronauts on board due to large pieces of foam falling from the shuttle's external tank, while also costing a whopping $13 billion. Space radiation is also a constant threat to astronauts, as humans only have limited tolerance to radiation. Galactic cosmic rays can damage DNA in human cells, cause mutations, and stimulate cancer, and in extreme cases, an acute dose of radiation can cause sickness, burns, and organ failure. In space, to protect astronauts against radiation, radiation shields are often added to the spacecraft. However, adding more radiation shields adds extra mass, meaning less room for scientific payload and astronaut facilities. In addition, when high-energy galactic rays hit a spacecraft, shielding may produce a shower of further energetic particles and radiation in the form of X-rays and gamma rays, which offer no protection for the astronauts during extravehicular activity. Other similar phenomena, such as solar emissions, may also harm space explorers. Debris in space is also a concern. Small and big objects float around in space and may easily enter the path of spacecraft. Since spacecraft travel at high speeds, the relative velocity of these objects to the spacecraft upon collision would also be high, and even the smallest rock may damage a poorly built shuttle heavily. Technology employed in space exploration must be designed to encounter all of these dangers. There are also the psychological implications of practically being stuck in an endless void for long periods of time. How would an explorer be able to endure all of this? Even assuming we overcome these hurdles, more problems may come into place. Should we even colonize other worlds? An economic and cultural divide between colonists and people still on Earth may drive political conflict. Adding further to the risks are the implications of contact with alien civilization, if any do exist. With our understanding of the universe today, how much of the universe can we actually explore? Are there any limits to how far we can go? Currently, only 93 billion light-years of the universe is observable to us, consisting of all time and space, matter and energy, filled with billions of stars, planets, and galaxies. But the entire entity of the universe still remains unknown. How much of the observable universe can we reach with our probes and spaceships? To be honest, not much of it. For one, it takes a really long time to travel in space. Just for a spacecraft to reach Mars takes around 150 to 300 days, and to reach Pluto will take 9.5 years. What if we were to explore outside our solar system or venture out of our galaxy? If we traveled at 17.3 kilometers per second, which is approximately 23 times the maximum velocity of a bullet, it would take us 40 billion years to get to the nearest galaxy that is like our own, the Andromeda Galaxy. This travel time is longer than scientists believe the universe has been around. Despite such odds, humanity has always had an interest in pushing beyond our limits, in hopes that someday we might travel beyond our world. With all that being said, what do you think of space exploration? Should we explore space? And where do you think space exploration will take us to?